Hello learners. After going to the first chapter of your syllabus and learning a little bit of Java program, we will now discuss about the basic building block of AP Java program, that is class, in this video tutorial. Now a class can be pictorially represented like this. A class consists of member variables or fields and methods. The general structure of creating a class look like this. First we should write the class, that is a keyword, then class name. This class name is user defined. We will choose that. It should be mentioned here that the class name should be a valid identifier. Then comes the member variables or field part of a class. Then the methods which we want to define inside the class. Now how many numbers of member variables or methods can be defined inside a class depends upon the need. If a class is defined generally to solve a problem or to model a real world physical object. Now as the need arises, according to that the instance variable or the number of methods can be found. For example, suppose we want to define a simple class vehicle which consists of 3 member variables. You can see the name of the member variables are those: number of wheels, body type, ignition type, and int, string, and again string. These are the data type of these member variables, and one method, namely input, is defined inside this vehicle class. As you can see, the member variables are those variables which are defined inside the class but outside the method which are defined inside the same class. So according to that, the variables, that is m, which is defined, you can see the m is defined inside this input method. It is not a member variable. It is a particular group of variable which is called local variable, which will come into our later part of this video tutorial. So all in all, we have created a class with some few number of member variables and a method. Now to make this class functional, or to make any class functional, we have to create object. An object can be created using this general form. First we have to write the class name, then the name of the object, then the equal to sign, then the new operator, then again the class name with a first opening bracket and a first closing bracket. This class name along with the opening first bracket and closing first bracket forms a special type of function named constructor. We'll discuss about the constructor in later chapters. For the time being, if you want to create few object of the class vehicle, we can do it like this. First, the name of the class, as the general structure suggests. Here it is vehicle, then the name of the object, then equal to sign, then the new operator, then again the name of the class with opening first bracket and closing first bracket. Here we have created two objects, namely v1 and v2. Creation of object termed as instantiation. So if someone asks what is instantiation in Java, we should say instantiation means creating object. This type of questions come into your class 10 ICSE final year questions. Now what happens after we create an object? Internally inside the computer main memory, that is RAM, it happens like this. A computer memory is a collection of storage locations. Each storage location is identified with a unique number which is known as the location or address of that storage place. Now whenever we create an object, a particular amount of memory get reserved. As you can see, both for V1 and V2 a few amount of memory is being reserved. Inside the reservation for each object there is place for member variables and for the methods. Here both for V1 and for V2 memory reservations are there for ignition type, body type and the number of wheels. One thing we can see from this picture is that number of wheels is common to both V1 and V2. Why it is like that? Because the number of wheel is actually not a simple member variable, it is a static member variable. So for a static member variable, whenever memory is reserved, that reserved memory will be shared by all the objects. We will come to the static member variable in the later portion of this video tutorial. Now let's concentrate on the object creation. How much memory will be reserved for an object is determined, and also that amount of memory will be reserved by the new operator. New operator calculates the required amount of memory, reserve the memory into the computer main memory, that is RAM, and allow the object to point that particular group of memory. So as you can see here in this line, V1 and V2, these two objects are created using the new operator, and as a result these memory reservations happen for V1 and V2. Now if we don't write the new operator, that means if we put a semicolon after V1 here, then what will happen is that no memory will be reserved against this object, and instead of creating an object reference will be created, and that object reference will contain a special type of value called null, N-U-L-L, which indicates that it is not an object, it is actually an object reference. Now after the object is created using the new operator, we can access the members of an object using the object name and the dot operator. The name of this dot operator is membership operator. What it tells to computer is that call the input function in this line, call the input function which belongs to object V1. This line tells call the input function which belongs to V2. Hence the membership operator or the dot operator is used. Now as we have created two objects here, naturally the question comes, how many objects we can create? Well, there are no limit theoretically. Obviously the RAM of a computer memory is limited, so practically the number of objects that we can create is limited by the amount of memory available, or the main memory or RAM available into the particular computer machine. Theoretically, any number of objects can be created from a class. Hence, the object or the class, I should say, also known as object factory. Here are few points about member variables or fields of a class. As you can see, a variable should be declared like this: variable preceded with data type. As you can see from this vehicle class, the member variables are preceded with their data type. The number of wheels is preceded with its data type int. The body type member variable preceded with its data type string. The ignition type member variable preceded with its data type string. The variables or fields are memory places where data for object can be stored. As you can see from this figure, both for V1 and V2, memory is reserved for its member variables. These are the memory places where data against this object V1 and V2 can be stored. So variables or fields are those declared inside class but not inside any methods. See, these are the member variables of the class vehicle. According to the point is that those variables which are declared inside the class but not inside any method are qualified for member variables. So number of wheels, body type, ignition type are member variables, but M, which is declared inside the input method, which is also happens to be declared inside the vehicle class, but as M is declared inside the input method, it is not qualified for the member variables. Hence, the member variables of the vehicle class is not M or N or B or I. Its member variables are number of wheels, body type, and ignition type. Variables are declared with data types that we have already seen. Access specifiers are used to restrict the access to the member variables. Access specifiers are private, public, protected, and default or package. These 2 points, access fifth and sixth point, are more related to inheritance and will be discussed in appropriate chapter. For the time being, we will keep it in your mind that access specifiers are used to restrict the access of the member variables, and the private variables, that means the member variables which are declared as private or has the access specifier as private, cannot be accessed from outside the class where it is declared. All the variables which we use in Java programming can be categorized into 3 types: instance variables, local variables, and static variables. Now, to see an example, we can again go back to this example, vehicle class example. Here you can see, if we want to declare a static variable, we will just put a static keyword in front of its data type. So this becomes a static variable. Now, what will happen if a member variable becomes static? From the point of view of memory reservation, static members will have a common memory location or memory reservation for all the objects. So no matter how many objects we create, there will be only a single memory location for the static data member of a class. Again, we will come back to this point in the latter part of this video tutorial. So if we want to make a member variable static, we'll just put a static keyword. This is a keyword before its data type. And if a data member becomes static, then there will be a common memory reservation for that static data member for all the object. Now, the local variables are those which are declared inside methods. Now, if we again look into the example of the vehicle class, here M, as it is declared inside this method, is a local variable to this method. Hence, or the N, B and I, which are also inside this input method, are also local variables. So the variables which are declared inside methods are known as local variables. Now we have already learned about the instance variables. To recall, number of wheels, body type, ignition type, these are the member variables or fields of the class vehicle. So the variables which are declared inside the class but outside the method of that class are known as the member variables. Okay, now we'll concentrate on the methods. Methods contains the code of a class. So as you can see from the example which we given for the namely the vehicle class, you can see apart from declaring the member variables, whatever we write inside a class should be inside a method. So all the codes which we will write apart from declaring the member variable inside a class should be written inside methods. Again, the access specifier comes into the picture. Private method cannot be accessed from outside the class where it is declared. This portion we'll keep in mind, but let's not discuss here because that will divert our focus from the present context. The interesting thing is that, or the important thing is that, this last point, program execution starts from a system defined or predefined function named main, except Java applications such as applet, servlet, etc. So what do we mean by program execution? See, when you write a computer program, our main goal is to solve a problem, and for that, through that program we give the computer some instructions to solve that particular problem, but computer has to know where it should start, or the point which can be considered as the starting point for that computer. And main is that function in Java which is the starting point of that work which we given to the computer through the computer program. So all in all, computer program is a set of instructions to solve a problem, and in Java computer program, main is the function from where computer starts doing or starts solving the problem according to the program. So main is the starting point of program execution. Okay, now how can we define a method? the general form of defining a method is being shown here. First, we will write the access specifier, then the static keyword, then the return type, then function name. After that, the parameter list. An example is also shown here to make it easier. As you can see, the access specifier, I have already told that access specifier can be either public, private, protected, or default. Default access specifier are those where we don't actually mention anything. If we don't write anything in place of access specifier, then it will by default access specifier or package access specifier. Okay, then comes the static keyword, then the return type. What the return type does, I am just coming into that point. Then the function name, here it is compare. Then the parameter list, and the parameter list can be written like this. First the data type, then the variable. Here the variables are A and B, and the data type of A is double and the data type of B is also double. Now here one point should be remembered is that the access specifier and the static keyword are optional. They are not mandatory. What does it mean? Is that whenever we require that, we'll put it. Otherwise, if we don't put, then Java will not report it as an error. Okay. So as you can see, we have here in this example, we have put all the pieces of general form of declaring a function. Access specifier is there, static keyword is also there. Yes, this return type is there. Then the function name, which is compare, and then the parameter list. Whatever we are doing here is the code for that is written inside this opening curly bracket and the closing curly bracket. This opening curly bracket and the closing curly bracket forms an important part of this method or the function. It is known as the body of the function. Now this return type, it is a very important part of a method. It is also mandatory. We often see that whenever we declare a method, we sometimes write void. As you can see in this example, here this input method is preceded with a void. This is also a return type. What void indicates is that this function is not going to return any value. Well, I am not pressing where this value will be returned. For the time being, just consider that after this function get executed, it is not going to return any value, and that is indicated to the computer by this void keyword. So here the return type is written as double, so that means it is not void, obviously. And what it means is that after the execution of this compare function, it is going to return a double value. Hence this return statement is there at the end of this function here return. And after that, that's return statement, one variable is there C, whose data type is double. You can see this double. This is not a coincidence that the data type of C is double and the return type of this function is also double. We have to do it. A function should return a value which is of same data type of its return type, or at least compatible to it. What does it mean by compatible will come later, but you can see as the return type of this compare function is double, hence it is returning a value of type double. Yes, this one. This is also, the method is also explained with another pictorial view. You can see a method, if we pictorially represent it, consists of two main parts: function header and function body. Function header, this part is known as function header. It consists of private, I mean the access specifier, then the static keyword, then the return type, then function name, then the parameter list. This first line of the function is known as function header, and the rest part, which is enclosed within the curly bracket, is known as body of the function. This is what pictorially represented here. The first line of the function is known as function header, and the rest part, which is enclosed within curly bracket, is known as the function body. Yes. Using function in Java consists two aspects. One is function call and one is function definition. Till what we have seen here, it is the function definition. In this slide, we are going to discuss about a very important concept of Java programming, how function works in Java programming. Now, before going into the details, we should know that there are two aspects of using function in Java programming. This is function call and function definition. As you can see here in this line, this is the function call, and inside the test2 class, the function definition is there. Now in the function call, we have passed some values which are known as actual parameter, and in the function definitions, those values are accepted into some variables. Here it is a and b. These are known as formal parameters. So to call a method or a function, we have to create object of that class. Here the add function belongs to test2 class, so we have created an object of test2 class t1, and using that object and dot operator, the function call takes place. Now after the function call is encountered by the program execution sequence, it jumps from the function call to its definition. In the definition, the intended work for which the function is used is there. That task is executed by the computer, and then the result will be returned. As you can see, the return statement in the last line of the add function, and the variable which is used in the return statement is z, and its data type is int. Also, you should notice that here int is written, which is the return type of the add function. In the next chapter we will go into the details, but for the time being you should notice this point. This is no coincidence actually. Anything in the return type of any function other than void is there, then the return value or the type of the return value should match the return type of the function. Here it is int. The type of z is also int, and the return type of the add function is also int. So after completion of the work, that is the addition of the two values which are passed into the add function, the value get returned and it's stored into the variable x, and that value get displayed here. So this is all in all an overview of how function works in Java. Now functions which are available in Java can be categorized like this. All the functions broadly categorized into two types: user-defined functions and system-defined functions. User-defined functions are those which are obviously defined by the users, and system-defined functions are those which are already defined inside Java. User-defined functions can also be categorized into two more types: accessor and mutator. Accessor are those methods which does not change the value inside any object, or in a formal language, accessor are those methods which does not change the state of an object. On the contrary, mutator are those methods which actually change the values inside any object, or mutators are those methods which change the state of an object. Let's understand it, or this group of classification, with an example. In this slide, I have discussed different type of functions available in Java and how they work. Although in the latter chapters we have gone into the details, but this slide will provide an overview of this concept. You can see here I have defined an math operation class having instance variable op1 and op2, and another instance variable final result, three methods: input, mult, and display. And in another class, test, I have created an object of the math operation class. Using that object, I have called the mult class with some values. As I have discussed previously, that whenever a function call occurs, the value from the actual parameter gets copied into the formal parameter. This will be the case here. So after this function call occurs, the a and b will have the value 3.5 and 2.8 respectively. Now, as you can see, the input function has the access specifier private, and the mult function has the access specifier public. As it is, the input function has the access specifier private, we cannot use this function outside the class where it is defined. That means we cannot use the input function, or we cannot call the input function outside the math operation class. But as mult function has the access specifier public, so we can use it, or we can call it outside the math operation class, as is the case here. In the test class and in the main function of the test class, I have created object and called the mult function using that object m1 of math operation class. But same cannot be done with the input function. That means if we write m1.input with some values, that will create an compile time error. You can try this in your PC if it is available. Well, after the function call of the mult function occurs, you can see here, from the mult function I have called the input method. As the call to the input method occurs inside the math operation class, therefore there will be no problem, and the input class will be called with the values of a and b, which happens to be 3.5 and 2.8. That value will be copied into the definition of input method a and b, and in turn that those values will be used to initialize op1 and op2. Okay, so using this input function we have initialized the op1 and op2. Now we have performed the multiplication operation on op1 and op2 and returning the result. This result gets stored into X and the value is displayed here. The point which I want to emphasize is that the display function, the merge function and the input function are different, in the sense that both in the merge function and in the input function, whenever a call to this function occurs, the value of op1 and op2 gets changed. As you can see, if I call the merge function once again with another set of values, then that value will be copied into A and B, and using those values the input function will be called, and again the value of op1 and op2 will be changed. So therefore, as many times I call the merge function, the value of op1 and op2 will be changed. Those functions which changes the value of instance variable are mutator functions. Therefore, input and merge function are mutator function. But in the display function, nothing like that is occurring. Here I am just calculating the square value of the final result variable using the pow function. Now the pow function accepts two arguments. For example, say if the final result has the value 5, then the pow function will return the value of square of final result, that is 25. Now calculating the square value is not changing the value of the final result variable. Therefore, the value of the final result variable will remain same even after calculating the square of it. Therefore, the display function is not changing any value. So it is an accessor method. The next thing which I want to emphasize is that you can see whenever I called a function, here I have called merge function inside the test class, and inside the math operation class I have called the input function. The function definitions are there, as you can see here. But for the pow function, there is no such function definition available in this program. So how does it work? The pow function is not an user defined function. It is actually a system defined function. The definition of the pow function is available inside Java. Therefore, we need not write the definition of the pow function as it is already available inside Java. So whenever we call the pow function, the definition which is available inside Java get executed and we get the result. Therefore, these merge function, display function and input functions are user defined function, and the pow function is a system defined function or predefined function. We have discussed in great details this user defined function, system defined function and the different type of functions in more details in the next chapters, which are available in the next videos. You can go through it. But this video gives a good introduction or an overview of the different kind of function available in Java. Now comes to a very interesting or important topic, that is static and non-static method in a Java program. Now a method or function can be static if you write the static keyword just before its return type. Here the return type of this display function is void, and before that we have written the static keyword. Hence the display function has become static. And the display2 function, as no static keyword is written before its return type, so it is a non-static function. Now what is the difference between a static function and a non-static function? To demonstrate that, I have created two objects of this test class where this one static function and one non-static function is being defined. Now you can see I have called the display1 function, which is a static function, using two method, using two object actually, and you can see both the call is associated with only one memory reservation. Here it is. But for the non-static method, two different call using two different objects associated with two different memory locations. For T1 it is separate memory locations, and for T2 it is separate memory locations. So from here we can conclude that call to a static method, no matter how many objects you create of a class where the static method is defined, will map to a single memory location. But for non-static method, using different object, function call will map to different memory locations. That is the main difference. Now here I have discussed, or I have shown some of the features of static methods and static member variables. First I have discussed the static member variables, then in the next slide I have discussed about the static methods also. But here in this slide I have discussed these features in the form of a difference between a static and a non-static, both for the member variable and the method, as you can see here. This will help you to understand how feature by feature one static member variable or a static method is different from a non-static member variable or a method. Let's start from the first point. Static variable can be declared using the static keyword, as we have already seen. A static variable can be declared using a static keyword just in front of the data type of the variable, and if we omit that static variable, it will become a non-static variable. Memory reservation for static variable is same for all the objects. That also we have seen. For a flashback, I am going into the picture here. Yes, here. As you can remember, if you not, then let's see this example. Here body type and ignition type are two non-static members, as no static is written before their data types actually, and the number of wheels is a static data member, as static keyword is written before the data type, that is int. So when we have created two member variables of this class vehicle, v1 and v2, see, for the non-static data member separate memory has been reserved, but for the static data member only a common memory is being reserved for both the variables. So no matter how many objects you create for static data member, only a single memory will be located, will be reserved. That is what is shown into this point. Memory reservation for static variables is same for all the objects, and memory reservation for non-static member variable is different for different object, as we have seen. Now static member variable, also known as a class variable, and can be accessed using class name and dot operator. As the memory reservation for static member variables are same for all the objects. Hence, to access a static data member or the static member variable, we need not create new object. We can access it using class name and dot operator. And as memory allocation for non-static data member variable for different object is different, hence they can be accessed with individual object and the dot operator obviously. Static member variable can be accessed by static or non-static member function inside the class where it is declared. Yes, and non-static member variables cannot be accessed inside static member function. To understand this point, I have written one small program, very interesting one. This test class consists two member variables. One is a static member variable and one is a non-static member variable. Now this display function is a non-static one, as no static keyword is written in front of this return type of this display function. So it's a non-static method or function inside the test class. Now inside this non-static method, I have accessed a, the value of a is being displayed, and also the normal or the non-static member variable b. B is the non-static member variable I have accessed inside the display function and display the value of b. Some value is assigned to b and that is displayed. Let's compile the program. Yes, as I compiled it, it is not showing any error, so it is absolutely okay. Now if I run it, it is run and the value of a, which is 12, is being shown, so it is perfectly okay, this line, and also the value of b is also shown or displayed into the computer screen. So from here we can conclude that a non-static method can access both static and non-static member variables. But if I convert it into a static method, let's see what happened. Yes, Java immediately gives two error messages. What are these error messages is showing here is that I have used b 2 times. B is a non-static member variable and we are trying to use this non-static member variable inside a static method, and it is the error message coming: non-static member variable b cannot be referenced from a static context. Here is the static context inside this display method, and it is b, which is a non-static member variable, which is used here. That's why the error. So non-static member variables cannot be accessed inside a static method. Well, that is what the last point signifies. Let's go into that. Static member variable can be accessed. Please pay attention to it. Static member variable can be accessed by static or non-static member function. We have seen inside the class where it is declared, but non-static member variable cannot be accessed inside static member function. Whenever I change the display method to a static one, then the error comes. So non-static member variable cannot be accessed inside a static method. Now static method, what it tells is that memory allocation for static method is same for all the functions call, even using different object. That is, we have seen here it is, even we are calling the display one method, which is a static method, using different object, then also the same memory location is being referenced. So memory allocation for static method is same for all the function calls, even using different objects. But memory allocation for non-static method call for different object is different. Here display2 is a non-static method, and using two different object, if we try to call the display2 function, that is associated with two different memory locations. Static method can only access static member inside the class where it is defined, as we have seen in the program just few minutes back. Non-static method can access static as well as non-static members inside the class where it is declared. Yes, association of static method with the class is done at the compile time. This is important. Let's go back to the previous example. Here you can see display2 method, the memory reservation for display2 method has been done twice in the computer memory. So if I try to call the display2 method without using the object, computer will become confused, as I have discussed. So that's why we have used object name along with the function to particularly mention which version of display2 function actually we are trying to use, trying to call. So for every function call there is an association with the memory reservation. Now when this association is done, that is what the last point of the table is saying. For static method, as there is no confusion because only one memory reservation is done for the static methods, that this association, that is function call with the memory reservation, is done at the compile time. And for the non-static method, the same association is being done at the execution time. Hence, for the static method, this association is known as early binding or compile time binding, and for the non-static method, this association is called late binding or execution time binding. Here I also want to mention is that, see, as memory reservation for the static member is a single one, hence no need to create object to call a static method. Only class name and dot operator is sufficient to call it. Hence association of static method with the class is done at the compile time. Hence this association is called early binding. Association of the non-static method with the class is done at the execution time. Hence this association is called late binding. It is also known as execution time binding, and the early binding is also known as compile time binding. The last topic of this video tutorial is the scope and the lifetime of a variable. This is very important. To understand that, let's take an programmatic example. Yes, this one. As I have already told you, this software is a freely available software named Dr. Java, and it is freely available into the in internet. You can easily find it. If you not, please let me know. I can give a copy of that to you. It is for tutorial purpose. You can use it in your home to run some of the example program which I have seen here. It is very convenient to use also. Thank you. So here in this program, you can see I have defined one class named test1. Inside that class, one display function is also defined, and inside that function one variable, it is a local variable, is declared. Now after that, I have created a block. A block of statement is a group of statement enclosed within a curly bracket. So here I have created a block of statement. Inside that block of statement I have defined another variable b, and here the value of a is added with 20 value, that is stored into b, and the value of b is being displayed. The interesting point here is that as the variable a is declared outside this block, hence a is available from this curly bracket to this one, this closing curly bracket, this from this opening curly bracket to this closing curly bracket, this one, this highlighted one. But b is only available to this portion. Hence this program where b is only accessed inside this block where it is declared is used only in that part, program will work fine. See, there is no error. If I run it, it works fine. If this message is displayed, I am inside display function, value of b is being displayed, here it is, and the last, the value of a is being displayed. So a is accessed here and the value of a is being shown, so a exists even after this block get executed. But say if we try to access the value of b inside the display function but outside the block where it is declared, this portion, outside this portion, here I want to access b by displaying its value. Let's see what happened. If we compile the program, Java announcing an error, cannot find the symbol b, this symbol Java cannot find. Why it cannot be found? Because the scope or the visibility of b up to this point, and also its lifetime also limited to this block only. Whenever computer leaves this block, here computer comes to this point, b just vanishes. So there is no existence of b outside this block. This is how scope and lifetime are related, or you can actually understand from this example how scope and lifetime works. Let's again compile it. See, if I put a comment or exclude this line from execution, program just works fine as b is declared here and also used inside this block. So all in all, for local variables within the block it is declared, where it is declared scope is limited to that point only, that portion only, and lifetime until control or computer leaves the block. When control leaves or the program execution sequence leaves the block, its lifetime over. What about the static variable? Its scope is throughout the class. Throughout the class it is visible, and lifetime until the program ends. That means as long as program is being executed by the computer, the lifetime of the static variable persists. Now instance variable or the member variable throughout the class except in the static method. Very important. So its visibility of the instance variable or the member variables throughout the class except the static method. If it is a static method, then it cannot access the non-static member variables. You recall that. Its lifetime until the object of the class stays in the memory. So as long as the object inside which the main instance variable is declared, as long as it stays into the computer memory, that is RAM, its lifetime persists. Now come to the definition. Scope of a variable defines the area of a program where it is accessible or visible. But the lifetime of a variable is the time up to which its memory reservation remains intact and does not get destroyed. Go through your textbook to actually grasp the definition written inside in your textbook. These are important because whenever you are writing answer in ICSE examination, you have to write the definitions which are given in your textbook. These are the homework for maximum 10 days. I think some of the programs I have already discussed with you in the first chapter. The last program or the last homework is a interesting one. It is related to a physical real world problem. Very interesting one, but very simple one, and also related to this chapter only. Please try and understand the problems which are given. These are very related to this chapter. Try to solve this problem using your own method. Whatever you have understand, try to apply those logic and solve the problem. Whatever you can do, that is only your gain. So go through this video time and again, your textbook, go through the definitions repeatedly, mark the important point in your exercise book, and solve this problem. Those who are having personal computer, please try to run the program, and those who are not having the personal computer, not a problem, you can always do it in your exercise book and do the program execution step by step, which I have taught you in the first chapter, known as dry run, into your exercise book. That will do fine. Actually doing the dry run in your exercise book teach you in a more clearer way than doing the program into the computer. So my advice is that who are having the personal computer, you can run the program in your computer, but you also do the dry run in your textbook. First do your dry run in your textbook and then try to run the program in your computer. Let's finish this homework within next 10 days. Thank you and happy learning.